Good morning, everyone. I think we'll go ahead and get started now. Maybe some people will trickle in, but for the sake of punctuality and the schedule that we have, we'll go ahead and get started. First of all, I'd like to thank Øredev for having me here, and I'd also like to thank all of you for picking my session over many of the other great ones that are going on at this time. My name is Travis Spencer, and I'm the CEO and founder of a company called Twobo Technologies. Twobo is a Swedish company. We've been operating since 2010, and we are only working on API security, and in particular working with OAuth and OpenID Connect, and how to use that to secure your APIs. So that's going to be the topic of my presentation. I'm going to give you a deep dive into what these standards are and the different actors and the different message exchange patterns that are involved in that. And I'll also, at the end, if time permits, give you a demo of that. Twobo is also the organizers and the producers of Nordic APIs. Have anyone heard of that? It's a community where we provide information around how to not only secure APIs, but also design them, how to monetize them, how to do different things with APIs. So there's lots of blog articles at nordicapis.com and also on the YouTube channel, past conferences that we've had around the Nordics and different places, and ebooks that you can download and take with you on the airplane or the train, wherever you're going back to. Twobo is also the provider of the Security Identity Server, which is an implementation of OAuth and OpenID Connect for doing very advanced authentication. It can do a lot of things that most OAuth servers cannot do, and it's really built for scaling large deployments. For myself, I'm an identity management specialist. I've been working on this problem and nothing else for the last 10 years. I'm American. I'm living here in Sweden, though, in a little village called Vårgårda, outside of Gothenburg, where I live with my family. So thanks again for coming. It's going to be a pretty short talk because API security is really just API keys, so we're done. This actually used to be like everything I would hear all the time, maybe about 3 or so years ago. People just thought like some random string is somehow providing enough security. But the thing about API security or API keys is that they're revocable, non-expirable bearer access tokens. If that doesn't make sense, they're symmetric keys, or said more simply, they're just secrets or passwords. So we need to do better than this. We have to be thinking about more if we're going to actually protect access to our data. So easy, right? We just have OAuth instead of API keys, and then it's secure. I'm afraid that it's not that easy either. There's more to it than that. So let's talk about what it is that we need to do to protect our APIs. It's even more than just API security. So we have to be thinking about enterprise security, and we also have to be thinking about mobile or endpoint security. I won't get into those other two aspects today, just the API security, but this problem is relatively big. But what's nice, and sort of as we break this hard problem apart into a more solvable problem, is that mobile security, enterprise security, and API security, at the heart of that is identity. Who is the person at the other end of that API? Who is the one calling this web service so that I can figure out what they're allowed to do? So in all three of those aspects, identity is central. And we have really, really good standards for that, much better than we had in the WS Star days, or even before then. We have great standards now, and they form this stack of or suite of protocols that we can combine to do things like delegated access for OAuth2, which we're going to talk about today. We can also do federation with OpenID Connect. We can represent our identities as JSON objects using the JSON identity suite. And this isn't just for representing identities either, representing keys, representing algorithms. And we can provision or create user accounts using SCIM, or System for Cross-Domain Identity Management. And we can do strong authentication in the browser using U2F. There's a lot of other ways of doing authentication, of course, but this is stacking it all up so that we can figure out who somebody is. And then we want to authorize access to that. And we can use that using a JavaScript type language called Alpha. I'm not going to get into that, but that's a good collection of standards that you can refer to. If you print all of these out, it will be over 2,000 printed pages in over 50 specifications, ranging from 3 different standards bodies. So you have a lot to figure out here, and so let's start unpacking this. So OAuth2, a lot of people think, okay, we do this, then we're done. What is even OAuth2? OAuth2 is actually not something that was ever meant to be implemented unto itself, because it's a protocol of protocols. It's a framework for other protocols. So even it leaves a lot of things undefined for the implementer or other standards writers to define and to specify and to build on top of that. And examples of specifications that do that are OpenID Connect, which we're going to talk about, but others like UMA for user-managed access, HART, which is a profile of OpenID Connect and OAuth used in the healthcare sector, primarily in America, but it actually has some really good profiling or definitions of OAuth to make it very interoperable. So it's a general purpose profile, in fact. And then OAuth in particular is solving a lot of important problems. One of those is delegated access, so that you can let someone else do something or do something on your behalf. And it does this in a way that doesn't result in any password sharing. So the applications that you're installing won't gain access to your credential. Instead, authentication will be sort of done outside of those applications, and we'll see how, and then provided a revocable token into those applications. So instead of that API key, that means that if we turn that or change that, then all applications are broken. Now what we have is a more fine-grained way of controlling access, where we can revoke one token and one application's access is revoked rather than all. In OAuth and those standards that are building on top of that, there are 4 primary actors. The first is the resource owner. This is the one that actually controls or is the one possessing the rights to the data. Usually this is a user, but it not necessarily has to be. It could be an organization, a company, something like that. But for simplicity, at the beginning at least, you can think about it as a user. There is then the client. OpenID Connect changes the word to be a relying party, but it's the same thing. It's the thing or the entity or the application that is trying to do something on behalf of the user. And then we have the authorization server. This is the thing that's issuing the tokens. More generally, you could call an authorization server a security token service. And in OpenID Connect, they call this the OpenID Connect provider, or the OP. These are all sort of synonyms. But the point of the authorization server is to issue a token. It's actually not its point to do authentication. That's left completely outside of the specification. It says that in many cases you must authenticate, but how is outside of the standard. But then once the user has authenticated and a token has been issued by the authorization server, that token is used to the API, and the standard refers to this as the resource server. Okay? How this looks to the end user. You've probably seen similar screens to this, where we have some sort of screen that's asking the user to log in or authorize access or get started or something like this. So the user will click on that, and the next thing that they'll see probably is some sort of way of logging in or identifying and authenticating themselves. And then what you may see, perhaps after that, is do you allow this application or third party to do something for you, such as have access to your profile, have access to your email, have access to your health records, your financial records, that sort of thing. So this screen is completely optional, and in almost all of our customer deployments, it's not shown to the user because it's in the employment agreement, or it's in the software license agreement of the application when you downloaded it and installed it. When you'll see this consent screen is usually when the application is being provided by a third party to the token service. So the token service is company 1, and then the app is company 2. So they want to have some sort of, do you really know that this third party is going to do so-and-so? So under the covers, what it looks like is this, where the client application will redirect the user to the authorization server. The authorization server will show that sign-in screen, and it might delegate to some other authentication service to do this, but by hook or by crook, the user will get logged in. And then an authorization code or an access code will be issued to the client. And this code then is a nonce, no more than once, a token that can only be used a single time. And this token will be sent to the authorization server. And you might think, like, why the back and forth? In this diagram, it's not shown very clearly, but what's happening is that that access code is going through the front channel or the browser, and this call here is going on the back channel or direct server to server. And that back channel call is actually authenticated. So now the user has authenticated and the application has authenticated. So we've got both of those entities identified. So then what it will do is a token will be issued. And in this token is encoded three things now. Not only the authenticated user and the authenticated application, but the token service is also authenticating itself, so to say, by signing a token or encrypting a token in a way that the resource server where we send this token to will know this came from a trusted issuer. And it is for such a user and on a certain application. To determine this, it will do a verification of that token. It could be done online, like by making a direct communication to the token server, but it could also be offline using a digital signature verification. But then that resource server will make an authorization decision and decide, should I release this data? And if it deems that it should, then the information will be returned. So this is one flow in OAuth. There are many defined. This is a popular one called the code flow. But there are others like implicit flow, which you might have heard of, and code client credential flow, resource owner, password credential flow. But this one is common where the application can keep a secret and can actually authenticate to the token server. Another thing that you may or may not have heard about in OAuth is something called scopes. Scopes are really fuzzy, like what they are. And as far as OAuth is concerned, they're a space-separated string, and that's more or less it. What you do with them is up to you. What people usually use them for is permissions, rights that the application needs in order to provide access to data by calling an API. So those scopes, if you could also think about them as a group of claims, if that helps you. So I'd like to have access to your first name, your last name, your Gravatar photo. All of that could be wrapped up in a single scope called profile, for example. So what it could also be is which information do you want to release to that third party? You can think of it that way. There's no standard ones like I mentioned, and sometimes you'll see consent screens not this busy, but this is where they manifest themselves when the consent is used. You're asking, do you want to allow that third party to do these sorts of things? In OAuth and OpenID Connect, there are lots of tokens, and there are two that we want to talk about first of all, which is the purpose of these tokens. And one is an access token, and one is a refresh token. An access token is kind of like a session, and a refresh token is kind of like a password. So like when you come to a website and you start making HTTP calls, at the beginning, it doesn't know who you are, so it challenges you to authenticate, and then it gives you a session. And then every HTTP call thereafter has that session ID, so you don't have to keep authenticating. So the password or the refresh token is able to actually get the user or the application a new access token, so it can prolong that session and not have to require the user to log in again. Does that make sense? Another way of saying it is the refresh token is sort of like a ticket granting ticket. It's one that the client can use to get a new ticket or a new token once the first one expires or runs out. The access tokens tend to be very short-lived, maybe 15 minutes to an hour, maybe even as little as 5 minutes. So this refresh token can help to really provide a good user experience. There are also different profiles of tokens. So we have bearer tokens, we have holder of key tokens. Pretty much everything that you see these days is bearer tokens, but this is changing to be holder of key tokens. Another word for holder of key tokens is proof of possession tokens, or POP tokens. To help you understand what these are, a bearer token is kind of like cash, whereas a holder of key or POP token is kind of like a credit card. If you're lucky enough to find 100 kroner on the street outside, you can go to Starbucks or the coffee shop and buy a coffee, and the barista is not going to ask you any questions. They're just going to give you your coffee. Whereas if you find my credit card and you go and try to use that, you first of all don't know the PIN, but if you try to just slide the magnetic strip, then the barista is going to challenge you and say, this token wasn't issued to you. So the holder of key tokens are tying the token to whom the user is issued to the one who's presenting it. So you're presenting that Visa card or that MasterCard, and it's not you weren't issued that card. So we can do that sort of thing as well with OAuth and OpenID Connect. This, by the way, is happening in a supplementary protocol called token binding. Types of tokens. So OAuth doesn't define any standard token type, unlike the WS star stuff we used to all do, where there was really clearly defined the types of tokens and the schemas of all of them. In OAuth, it's just kind of like, whatever you want to do, you can do it. And at the beginning, this was really thought to be a problem or a deficiency of OAuth, but it's actually proven to help with interoperability, so I can integrate legacy systems and the tokens or the credentials that they might want and still conform to the OAuth specification. So you can use those old WS star and SAML tokens. That works. That's fine to do. You can also create custom or homegrown tokens. This is actually the most popular form of token, which is just some random bits and bytes that are ASCII armored and used as a token. You could also use a CBOR web token, which I don't have time to go into today, but you can also use a JSON web token. And a JSON web token is pronounced like the English word jot, to write something quickly as a sort of scribble. And jot tokens are security tokens that are encoded in JSON format. So this results in a very low tech barrier because finding JSON parsers in more or less every language is a lot easier than an XML parser that adds a higher technology barrier to the implementer or receiver of those tokens. So they're meant to be very lightweight. Everything that can be removed is, equal signs at the ends of the padding for padding is dropped. And the point here is that these small little mementos are passed in HTTP headers and in query strings, so it's trying to be as compact as possible. There are auxiliary standards for actually binding this into the body as well, but I won't have time to get into that today. They are less expressive, less security options than SAML tokens if you've worked with those, but really providing enough of what all of us are doing on a daily basis. We also have different ways of passing tokens. So we can pass tokens by value or by reference. So for the programmers in the room, you probably already understand what I mean, but in case you don't, or it's been a while since you worked in a programming language with pointers, what I mean by this is that when you call a method or function and you call it by value, you put all of the information on the stack, and then the receiver of that message has the information right there and can act upon it. The other calling pattern is by reference, where you put a pointer to the information, the receiver of that message has to dereference it to have access to that information. We can do the same thing with tokens. So in by value, which a JWT token is a by value token, a SAML token is a by value token, all of the identity information is encoded within that token. It's typically signed or encrypted then to protect that information. On the other hand, a reference token is just some bits or bytes or some string of information that points to the identity data. So remember I said those homegrown tokens are actually the most popular method of representing user information as tokens, and in that way, there is pointing to the identity data, which is stored somewhere else. Does that make sense? We're going to get into how this actually can be used in a real-world deployment in a little bit, so remember that. I jokingly said at the beginning of this talk that OAuth will solve all of our API security challenges. And of course, you're starting to see now the complexity of it, and maybe after working with it a little bit, you've already seen that. But what I want to also point out here is that OAuth has its place, and it should be used for what it's designed to be used for, and not what it's not intended for. And as I already told you, OAuth doesn't define anything to do with authentication. Authentication is about identifying and figuring out who somebody is, and that's not what OAuth is doing and defining in its exchanges and its message exchange patterns. So it's not doing authentication at all. It's not doing federation either. Federation is figuring out who somebody is in one security context and reusing that in another context without having to ask them again. This is not about federation whatsoever. And it's also not about authorization. What is authorization? Authorization is deciding that you can do something. So you would think, oh, auth, I mean, what is the auth part? It's either authentication or authorization, and this guy is up here telling me it's neither. Yeah, it's neither. It's a misnomer, actually. What it's designed for is delegated access. To understand the distinction between authorization and delegation, let me give you a metaphor. Suppose you're a business owner and you hire an assistant to help you with the bookkeeping. You delegate to that bookkeeper and say, you can go to the bank and take money out of the business account and use that to do the business's things that it needs to. Okay, so now that assistant has been delegated rights. The assistant goes down to the bank and says, I'd like to take out 100,000 kroner from the business account. And the teller is going to say, I'm sorry, you're not allowed to do that. And the assistant is going to say, but I've been given that right by the owner of the company. And the banker will say, well, paperwork hasn't been signed, signatures haven't been provided, so you're not authorized. You may have been delegated some rights, but those rights do not authorize you because insufficient procedures or processes were done. So I can't, as the banker, feel comfortable giving you that money. So OAuth is about actually giving rights to someone or something to do an action on behalf of some user or resource owner, but it's still up to the API or the resource server to decide should it be able to do that. And it's really in the best position to do that because it's right close to the resource. Does that make sense? We can argue about the semantics later if you'd like. I get into that sometimes with people, but that's my firm opinion of how this stuff works. So OpenID Connect, as I said, it builds on top of OAuth. It's providing a couple really important things because OAuth isn't for authentication and it's not for federation. Everyone started sort of bolting stuff on and adding extra stuff into there so that we could do this stuff because this is actually what we want to do. So Twitter came up with their way, and Facebook and Google and Box and Salesforce and everyone was just kind of like, time out, let's like, now that we have a standard and it's a framework, let's use that framework to actually solve these other problems which we all have. And that is that the application wants to know who logged in, how did they log in, when did they log in. The only token that's being issued in OAuth is for the API. So the app sort of got left out in the cold. So OpenID Connect, it gives us another type of token. So I talked about access token and refresh token. Now we get another, which is called the identity token or ID token. And this one is intended for the app, the web app, the mobile app, so that it can see who logged in, how, when, what's their first name, what's their account number, information that the app needs. And it does this in a way that we can receive it in a token, but we can also get it from an API called the user info endpoint. And the user info endpoint is sort of a releasing of user information that has been authorized or delegated by that user. OpenID Connect is sort of like the third version of OpenID. So it's not compatible with OpenID 2 or 1 in the same way that OAuth2 is not compatible with OAuth 1. So let's look at the flow. This is the same code flow as before. OpenID Connect adds in additional message exchange patterns on top of what OAuth does, like the hybrid flow. But I won't talk about those. But this one is the code flow like we saw before. In this request, it sends over a scope, and the required scope that it must send is OpenID, and that clicks the OAuth server into OpenID Connect mode. So now the OAuth server will log the user in, however, also doesn't say. We still don't have an authentication protocol or an authentication standard here. But by hook or by crook, the user gets logged in, and that access code or authorization code is sent back to, now we call them the relying party, the client. The client will then redeem that code, and in doing so, authenticate itself, and we'll get back an access token, and also now the ID token. So this guy can see how the user logged in, when, all this stuff, and have that access token to start calling APIs. One of the APIs that it could call is that user info endpoint. So if it wants to get additional user information, it could call that API to receive information or claims about the user that the user has authorized the application to receive. So the ID token, as I mentioned, is for the client. The access token is for the API. That's really important. And that's why not understanding that distinction is how people get into trouble and start to use OAuth when they should really be using OpenID Connect. So be aware of those distinctions. The ID token is providing information about the client who is actually being used, so that that identity token can be taken to other applications. So it's sort of binding that ID token to the authorized application, so the app can see like, hey, wait a sec, this ID token isn't even for me. This is always a by value token, and it's always a JWT token. So the standard actually specifies that as a requirement. And in there is information about the issuer of that token, and also when it expires, which could be useful for creating a session that is teamed to that ID token's expiration if you wanted to. The user info endpoint, obviously, maybe not obviously, but its obvious intention is to use it as a way of getting user information, but in practice, in the first bullet there you see it also can be used for token issuance. So it's sort of a shotgun where you can then like issue a bunch of tokens out of that API call into the client application, which it might use to call a bunch of different APIs. Kind of a useful trick. The authentication and how the user authenticated can be included in the access token and also taken into account when calling that user info endpoint. Some details here about scopes and the sub, but not really important for just now. So now let's start to use all these things. We talked about OpenID Connect, we talked about OAuth. How might we put this into practice? So normally when we build applications, we have different components of different kinds, and to scale an application with all these different components, we have to have different instances of it. And this has been fine. This has taken us a long ways in IT, but we're starting to rethink this and to think that the component itself should be a service. It should have its own life cycle that should be independent of the other components, and we should run these as microservices so that we can have each one of them autonomous, right? So this is the hope and the goal here is autonomy from these other microservices. If we succeed in that, we can scale these separately. So we don't have to take our entire application and have a brand new instance of it. Each microservice, if we need more of them, could be added in as required. So what's the problem here? Well, in a monolithic application, the way of securing it was that we would come to some sort of middleware, perimeter, or firewall, and we would receive or check some sort of token to or session or something to figure out that the user logged in and how they're logged in, and that they can actually consume the components within this application. And this was done with some sort of interaction with the user repository. If we follow that pattern, now as we build microservices, we've already established an anti-pattern where every single one of them has this shared dependency. So they're not really microservices anymore. They're just microservices or components dressed up as microservices, but they're really still sharing the same dependencies. Does that make sense? Agree with that thesis? Well, I do anyway, and I don't think it's fantastic. So what I'd like to do is take advantage of these different ways of passing tokens around and make every single microservice autonomous unto itself, so that it doesn't have to consult a user repository, so that it doesn't have to share that data about the user. What I want to do is I want to include no user information in my tokens that is outside of the network or outside of that microservice network that I'm building out. And then I want all of the user information to actually be in a by value token as it comes into the microservices. Because then what will happen is the microservice will have a very easy time doing an offline verification of the user information by just checking, is this token valid? As long as it has access to the private key of the public key of the token server, it can check a signature and will not need to consult any user repository or user database. Does that make sense? To help you understand a little bit more, here's another picture where on the outside we have that ref token that contains no information. It's going to travel through probably some sort of middleware that could actually be encoded into the API, but it could also be done by a more heavyweight proxy or one of these service routing applications like Zool or something. And it will convert it to a by value token inside that microservices network. How is that done? Well, this middleware will come in, receive that reference token, and do a conversion sideways into a reference token and cache that, and then send it back into the microservices. So now I've introduced state into the network, which in my opinion is okay, because this state is just a mapping between these two pieces of these two kinds of tokens. And if you have a cache miss or you come into a different service proxy, you can do the dereferencing again and cache it in that one. So it's not a shared distributed cache. Make sense? Yeah, please. What is this reference? What, sorry? Yeah, so these are bearer tokens. If you find 100 kroner outside, you're a very lucky man and you can go buy a coffee. So if you want to protect yourself against that, you need to issue holder of key tokens, so that that possibility of stealing tokens or finding tokens is impossible. Other questions? I'll go into a demo otherwise. But do you guys have other questions? All right, super. So let me show you some of this. So here I have an application. This is my OAuth client, or in fact my OpenID Connect relying party. And here, as I said, it starts with authorize, signing, get started, that sort of thing. So I click this button, and behind the scenes, it's going to start the OpenID Connect code flow that I described to you in that picture. And this is using the security identity server, which I told you we're providing. This delegates to an authentication service. I can log in with a username, password, or with bank ID. Those are my options there. So I choose to log in with a username, password. So I go ahead and do that. And now I get redirected back to the OAuth server, who sees, okay, this application is using OpenID Connect, so I'll issue it an ID token and an access token, and because it authenticated, I'll give it a refresh token. So what you see at the top of the screen here is information about the user. This came in that by value JWT token that I talked about, and in that information we can see how the user logged in, when they logged in, and this payload or this bit of JSON here is actually signed, and the top part is telling me with what key, a key with -38 blah 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 as an identifier. So the application can verify it as long as it has access to that key. Where it can get that key is provided by the OpenID Connect server in a standard sort of API where I can find the key ID -38 blah 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 and see that, okay, now I have that key, I can run that through, this stuff through that, and I should get a matching signature, and then it's okay and it's valid. So now I get this access token, and this is that by ref token that I talked about. So what's nice here is like this information about the user might be less because this application might not be as trusted as an API that's in the backend. So what's in that token doesn't need to correspond to what that one refers to. It could be different. So that reference token, what I can use that for is to actually call the API. So let me make an API call. And now it can see, like, look, John logged in. How did it know that from a GUID? Well, it did that dereferencing that I talked about. So to simulate that, let me grab this access token, and let me switch over to Postman and pretend I'm pretend that I'm the API, and I'll paste this token here. And I do that by calling this introspection endpoint, which you can see here perhaps, if I make it bigger. So I have the token there. I have a client identifier, which is different from my other one. This is like a gateway client, and I do that introspection, and I get back some JSON code. And this is probably a fine way to do it if this isn't an actual gateway, but the API itself. If it's the gateway, it wants to forward that by value token. So what I can do is I can just change and say that I, as the gateway, accept application JSON, make the call again and do the introspection. And now what I get here is a JWT token, which when I look inside that JWT token, I can see here that, yeah, it's this, it's these scopes. It's John Doe who authenticated. And more questions? I only have like 3 minutes, so I'll show you something else if there's none. Okay, so now what I can do is I'm logged in. If I click restart the login flow, SSO kicks in, and I don't have to log in again. But I can actually do like a step-up authentication and say, restart the authentication, but ignore any SSO and actually get them logged in with bank ID. So now I no longer have a choice of log in with bank ID or log in with username and password. The application wants me to log in with bank ID. So I'll go ahead and do that, and maybe I'm connected to the internet. So maybe this will work. Yeah, seems so. So I'll log in with bank ID now. For those of you who don't know, bank ID is a Nordic eID provider that most Swedish people have. Their equivalent in other Nordic countries. So now the application can see that the user logged in with bank ID. And I can even see that in the access token if I wanted to introspect that. And now the username has changed from John Doe to my personal number. That's not my real personal number, we're not that young. But now the application can do that authorization like I was talking about. And the API can do that authorization, and it can do that authorization by looking at which application it's using, which of these flows it's using, and also how the user logged in and the strength of that credential and your confidence in the user really being who they say they are. Does that make sense? Okay, I got 1 minute if there's a question. Otherwise, I'll thank you all for attending. Excellent. Thanks.